Swayam Prabha. Digital India. Educated India.
Dear students, we are back to the class of geometric design. We have started with the side distance requirements, and today also we will be interacting on side distance requirements, basically the factors which are going to affect the side distances. What we have covered in the previous lecture is the road margins and the road length, and then we talked about the building line and the control line. These two aspects were related with the space requirements which needs to be acquired for any category of road which is to be constructed in an area. After that, we started our discussion on the various side distances, and the very first thing which we have discussed was to examine and categorize that what are the various types which are there, and then we have looked at the broad categorization of the factors which affect the side distances, and then finally we were talking about the first factor, that was perception reaction time. Now, from here we are going to continue forward, and what we are going to talk today, they are friction between tire and pavement, the overtaking maneuver time, the acceleration rate of vehicles, height of driver's eye and object, and headlight beam angle. Now, if you look at these factors, they are not specifically related to one type of a side distance, they are related to all such side distances which we have otherwise talked about in terms of their types. And as per the requirement, out of these factors we are going to utilize them one by one. Now, if we talk about the first factor, that is friction between tire and pavement. Now, in this case again we have a set of factors which are going to affect. And if you look these factors, what you can find is that they are either related with the tire, or they are related with the pavement, or then they are related with the vehicle characteristics. The reason is simple, all these vehicles they are moving on a pavement, and therefore, the interaction of vehicle with the pavement, which is in terms of the tire and pavement interaction, and the requirement of stopping the vehicle in terms of applying the brakes, or the speed at which the vehicle is moving when something is to be done in terms of the side distance requirements, they are being causing that why all of these factors are going to be there as a factors which affect the interaction between tire and pavement. When we look at the set of factors which are related with tire, there are two things which are coming up. One is what type of surface condition is there on the tire, whether the tire is a new one. So, if it is new, then you will find that it is a completely treaded tire, that means the grooves are there on the surface of the tire as required, or otherwise it may be a condition where the tire has been used for number of years and therefore it has worn out. And when we say worn out means all those treads which are there, they have slowly gone, or the depth of those particular treads as well as the width of those treads, they are continuously reducing because of the use or because of the interaction of the tire with the pavement, and finally it is coming to a smoother surface. So, this can be one reason which may affect the friction. Obviously, when you are talking about the treaded tire and when you are considering it with respect to the worn out tire, the worn out tire is going to create a smooth surface, but it will going to provide more of the contact area if it is in a worn out condition. In the case of treaded tire, the contact area is going to be with respect to the treads which are projecting outside the overall base surface of the tire. But then when you are looking at these two things under different operational conditions, they are going to react in different form, and therefore, the frictions are going to be different. So, we will be talking about that also in the subsequent slides. Another effect is that how much air is being filled in the tire, and that is going to be there in terms of the tire pressure. Now, when you are talking about this tire pressure and the air is less, then in that case the area of contact of the tire with the pavement is going to increase. But if the tire pressure is more, then the amount of area which is going to be in contact with the pavement is relatively lesser. Now, when this type of thing is happening, we are not talking here in terms of a load distribution, but in terms of the contact area which is going to generate the friction. And again this becomes one such factor which needs to be taken into consideration. The another two factors which have been listed here, they are related with the surface of the pavement, and the surface of the pavement has been talked in two forms. One is what type of condition is there of the pavement, and another one is what type of material is being used so as to construct that surface. Now, here again if we talk about the condition of the pavement, if the pavement is the new one, then we assume that this pavement is quite smooth, but over the period of time you may find that the deterioration is there, the distresses are there, and that causes the pavement to become rough. So, some material may come out, some layer deformation may be there, or any other thing which is happening on the surface of the pavement because of either the traffic or because of environment is going to make it rough. So, when the pavement is smooth, then with respect to the pavement when it is rough, obviously you can understand in which particular case the friction is going to be less or in which case the friction is going to be more. The other case can be that we can talk the pavement in terms of whether it is dry or it is wet. If you go into the geometrics, then in that you must be coming to know that there is a camber which is being provided which tries to keep the pavement dry. So, whenever the water is coming at the surface needs to be drained out, but in some cases it may happen that the flow is such that it remains wet, and if it remains wet it is also smooth, then probably this is going to create a one of the worst conditions with respect to the reduction in the friction. So, we have two sets here, one is in terms of the moisture effect, another one is in terms of the rideability effect, and these two we can talk separately as well as we can talk in combination with each other. The same thing which we are talking in terms of a smooth or rough can also be talked in terms of a material being used so as to create that surface, where we can have a cement concrete, CC is for that, or it can be a bituminous black top surface. It may be the gravel material. So, the aggregates which are there and they have been mixed with the soil and that sort of a surface is being provided, or it is a simple earthen road. Now, in all of these cases also, if we assume everything is ideal in conditions, everything is good, they are all new, then again you will find that the friction is going to change with respect to these type of surfaces. So, the CC pavement if you have is going to provide a more smoother surface as compared to the bituminous one, where there is a possibility of the aggregates protruding out of the surface and thus creating a friction in the surface. So, when you are going in that form, so you may find that if you move in this direction probably the friction is going to increase, but again then you have to see that there can be the combinations which may cause the friction to increase further or reduce it in certain conditions. One point which we need to talk is the temperature effect, and this temperature effect is for both the pavement as well as for the tire. Now, when you are looking at these two components, pavement and the tire, because of the solar radiation, the pavements will keep getting the temperature, there is a accumulation of temperature and the temperature will become even more than the air temperature here. And when the tire is moving on the top of it, because of this interaction, the air inside the tire, that is also going to expand if the temperature is increasing. So, now the problem is here that if the higher temperatures are there, what is going to happen? And because of this higher temperature, when the air is getting expanded, then it is culminating into the higher tire pressure, and if the tire pressure is increasing, then again what type of a problem can be there. In some of the news you might have heard that on the expressways which have been constructed with the cement concrete pavements, there has been cases of the tire burst. The reason being that they started their journey with a good air pressure inside the tires, without understanding that when they will be moving on these particular pavements, then because of the temperature effect the air is going to expand, and then finally the tire got bursted because of those higher temperatures. So, we need to see that at what particular type of pavement we are driving our vehicles, and accordingly what should be the tire pressure which should be maintained, and for how much time period are you going to drive on that continuously, or even with the momentary stops, the 10 or 15 minutes stops are not going to make much difference, and that is where this is one another aspect which is going to create an impact on friction between the tire and pavement, and we need to look at it. Then the two factors which are being listed at the bottom, they are related with the vehicles. One is with what efficiency the brakes are being applied, and we usually consider the worst condition where the efficiency is 100%. Obviously, if the brakes are not being applied with the 100% efficiency, they are something like 70-80%, the distances by which the vehicle is going to stop is going to increase. And we will try to see the effect of these when we will subsequently talking about the distances in our subsequent interactions. The speed of vehicle. Now, this is also going to create an impact, and it is being observed that this friction is correlated with the speed of vehicle, and as the speeds increases the friction values are going to be reduced. So, let us move ahead and see that what type of things are going to happen here. Now, the first thing which is being taken here is related to the tire condition, and we see here the two type of the tires. One is a new tire where you can very clearly see the grooves which have been created. So, we have the grooves being created in the along the rim or across it, and this is going to provide a sort of a grip depending on in what type of a surface this tire is moving. Whereas, in the other case for the same one you can see that it has almost flattened, and therefore, all of these whatever grooves were there, they are not there, and if now this is touching the pavement, the contact area is going to be more. So, this is how it is going to make a difference. So, if you do the study using these type of things, one study and the material from there I have included here, where what you can see is first of all the effect is being defined with respect to the season. So, we have the summer versus winter, and the comparison for summer versus winter has been talked in terms of the tread which is 8 mm in both the cases, and how it is going to make an impact in terms of the distance by which the vehicle is going to be stopped. And what you see is in the summer period, for the same conditions of tire and for the same conditions of the pavement, it is taking more distance as compared to the winter. That means the temperature is also playing a role here. But when you talk about the same season, and when you keep on reducing the depth of the tread, that means we are getting the tire worn out. So, what we found is that the distance by which the vehicle is going to stop, if it changes from 8 mm to 4 mm, so the depth has reduced by 50%, your distance is increasing again by 1.5 times of what it was there when the threads were 8 mm. And when it has reduced further, even further less than the half of the previous value, what we found is that it has now gone to a much higher value of 60 meters. So, there is a clear cut distinction of the effect of the treads of a tire with respect to the distances which are required by which the vehicle is to be stopped, and of course, when you are applying brakes, when the vehicle is moving on the pavement, the rest of the resistances are still there, but they are not being playing in that sense as they were playing in the case of the first one, where the treads were 8 mm in winter and the distance was roughly around 35 meters. Here we can look at the effect of tire pressure and temperature together. You can see that on the x axis the temperature is being shown, on the y axis there is a pressure, and there are two cases being defined. One is for moist air inside, and another is the nitrogen is being filled in the tire. Now, what you can see is that as the temperature is increasing, after a certain point, say 100 degree in Fahrenheit, the distinction between the two curves is clearly visible. In the case of moist air, the temperature when it increases, the tire pressure is coming roughly around 45, but at a value of 200. In the case of nitrogen, it is less than 35. So, what type of matter is being filled in the tire is also going to make a difference, and one reason of filling the nitrogen is that it keeps the tires cool, and as well as soon as you have stopped your vehicle within no time, or we can say a reduced time period, your tires are going to become cold. So, this is one study related to the nitrogen versus the moist air, but what you can see is that this effect is something like exponential, where in the case of nitrogen it was more or less the linear change which was there in the values of pressure. Here in the other diagram, what it tries to show is the contact area which is going to be there. If the higher pressure is there inside the tire, then you get an imprint like this, but when you are talking about a lower pressure, then the whole width of your tire which are being talked in terms of R values and all. So, that is going to make an imprint, and therefore, amount of contact area which is going to be there is more, and that may help in the creation of more friction, depending on again the first other conditions, that what type of tire it is, what type of surface is there. Now, here we are talking about the dry and wet pavement surface. Now, before I talk about the certain diagrams which have been given on the left hand side, let us see that what is happening in the case of these graphs, where the reaction distance and the braking distance are being talked for a particular speed, and our assumption should be that whatever is the condition, the vehicle should stop at the same point, but that is not the case. What you found is, as the speed is increasing in this direction from 40 kilometers per hour to 100 kilometers per hour or 110 kilometers per hour, the reaction time as well as the braking distance, they are increasing. So, we find that all these values are increasing in this direction, and at the same time, if your pavement is wet, then the values are further increasing. And what you found that if you talk about 100 kilometers per hour, it is something like already around 25% increase is there in the value of the distance by which the vehicle is going to stop. So, this is an effect which is coming, and now why this effect is coming is probably we can try to understand from these two figures which have been provided here. So, when you are talking about a tire which is moving on the surface of a pavement, now surface of the pavement is being talked as smooth, but say if you are talking about in actual at a micro level, then it is not smooth, it is going to be something like this. So, they are going to be protruding items in terms of aggregates maybe, which may be coated with bitumen, and then they are providing this type of a surface, and when the wheel moves at the top of that, then it is contacting those aggregates or those surfaces at certain points, at some points it may not be contacting. So, you can see that at this point or at this point it is not contacting, but at this point or at this point, or when the pressure is lower and the contact area is increasing, we found that in this particular area there is a complete contact of the tire with the pavement. Now, when this type of thing is happening and there is a very small amount of water which is present on this surface, then this water is going to splash out, and therefore, not much of the effect is going to be there. But when this amount of water is going to be increased in its thickness, then what happens is the initially it was supposed to be a good contact, but slowly this contact is going to be reduced, and finally, you find that there is a sort of an aquaplaning condition where a water film comes between the tire and the pavement, and the tire is expected or is assumed to be moving on that water film, and therefore, the friction is being reduced a lot, and at this point of a time if the brakes are applied, then it may also culminate into an hazardous situation. Let us look at the effect of the pavement surface condition. Now, here the pavement surface condition is being talked in terms of the dry asphaltic surface or a bituminous surface, or you can say the blacktop surface. And another one is which being shown on the other side in the photograph, where the snowfall has been there and then slowly that snow has settled down, and now it can be treated as a black ice which is there in terms of crystals at the top of the surface. Now, this black ice which is there, you can see what has happened to few of the vehicles on this side, which has been shown in the photograph. You have to be very careful while you are driving on this and you apply your brakes. You cannot apply your brakes with the full efficiency. If that happens, then your vehicle is going to be wayward in any of the direction, and if you are in the hilly area, on one side you have a hill, on other side you have a valley, then again the person can lose the life. So, here we are looking at that effect, and what we found is at the speed is increasing on the x axis and we are taking the stopping distance to stop the vehicle on the y axis. If in the case of dry asphalt, we are going to stop the vehicle at 150 meters. In the case of the black ice which is there at the top, you are having a value which is something like 325 at a speed of 100 kilometers per hour. So, it is almost more than doubled in this case. So, that is what is an impact which is going to be there. So, in the hilly regions, when you are talking about providing the stopping distances when those areas which are infected by the snow, then we have to look at that what type of things needs to be provided. Here again another thing is being shown in terms of the either the beach sand or the sand in the desert. One of the difference which is going to be there in the case of beach sand versus sand in the desert is a amount of moisture which may or may not be there. It all depends what particular portion in the case of beach you are running your vehicle. You can see the type of the treads which are there, the bigger wheels with wider area, they have been used here. The point here is that when you are using these type of things and you have a loose sand, then it is better that we reduce the tire pressures by 20%. Otherwise, there is a possibility that tire will move inside that loose sand and you will not be able to move your vehicle ahead. Okay, so that is what is being talked, or you have to deflate the tires. But yes, one thing which has to be kept into mind is that as soon as you are out of this system, you need to improve upon the tire pressure, otherwise it is going to be a problem for the vehicle when you are driving under the normal condition. So, what type of grip is going to be there in terms of these type of materials versus the water versus the surfaces, all of these things together they define that the friction which is going to be there, what value we should consider. Here the surfaces have been shown, you can see that it is a maybe treated as a very smooth surface. Here in this case you can find out that some irregularities are there, or you can probably say a bit rough, whereas this is a surface which has broken down. So, you found that there are lot of cracks etcetera which are there in the longitudinal and the transverse direction of the movement, and these are also the things which are going to cause the amount of friction with which the vehicle will be moving and traversing these sections. So, obviously, the things may be going to be more in these cases and then relatively less in this, and then finally less in the third one is what we are probably should be aware of. Here again you can see the different type of surfaces are being shown. You have an say earthen surface, you have a gravel surface, this is a cement concrete pavement, and this is a pathway which has been created by use of stones. As you can see here in this case, the friction is obviously going to be the highest. In this one the frictions are going to be the lower one. If this earthen surface is well compacted and there is no effect of moisture, it is not making it muddy, then the frictions can be lesser, but if it is becoming muddy, then the frictions are going to increase, but it becomes more muddy, then friction is further going to reduce, because now the slipping conditions are going to be there. So, it all depends on what amount of moisture is there in the earthen surface will further define how it is going to react in terms of the movement of a vehicle. These type of paths usually you may not find, but in many of the places now they are using stones so as to provide the roads also, and that increases basically the the discomfort to the drivers as well as the passengers, and the vehicles moves at a lower speeds, and that is how we create the unhazardous situation in those cases. So, what we can talk is that we can always say that there is going to be a combination of all of these things, and those combinations can be like, we can say there is a tire which is treaded, but the surface is wet. If the surface is wet, then the water is getting into those treads, and therefore, there is going to be a grip and the friction is not going to be that much less. But if you talk about the worn out condition along with the wet, then this is going to create a hazardous situation. So, likewise, if we try to make, we can always make these type of examples where they are either increasing or reducing the friction on the surface, and therefore, this is going to be a one big problem, and we have to see on that. Here I have given one example of a formula races where the vehicles will be moving at a speed of something like maybe 200 kilometers per hour or more. Then how they have been able to do that? One is that they have the aerodynamic bodies, the another is the size of the vehicle is very small. So, the air friction is going to be reduced, and the third thing which they are controlling is in terms of the friction which is being imposed by the pavement on which those vehicles are running, and in the dry conditions they use these type of smooth tires. But if there is some small amount of water which is coming maybe due to drizzle or something, then the intermediate tires are used. But if the tire of those surfaces are going to be wet, then they also use back to the basics, that the treaded tires are going to be used here. So, that is how they keep changing, and accordingly the speeds are going to be affected. Now, coefficient of longitudinal friction which is there is going to be dependent on speed, and has been shown here, and I talked about that. As the speed is increasing, the values are going to be reduced. So, when you have a speed of 20 to 30 kilometers per hour, then this is 0.4 only, but when you comes to 80 to 100 kilometers per hour, then it becomes 0.35. So, it is changing as the speed is increasing. Changing here, we can say that it is reducing, and these are the values which we will be using when we will be talking about the braking distances or the stopping distances to be discussed in the coming interactions. Another case is a overtaking maneuver time. Now, overtaking maneuver time is the time where you was there in this vehicle which was moving at a certain speed. There is another vehicle which is moving at a speed V2 which is going to be less than V1, and then you are interested to cross this vehicle, go in this direction and then come back to your own lane. At the same time, there is going to be a vehicle which is coming from the other direction, maybe at some speed V. So, when you started doing following the vehicle and overtaking and coming to this one, so here following is also going to be there, because you have to see whether the opportunity for overtaking is there or not. All of these things together, if taken together, then that is what is an overtaking maneuver time. And this overtaking maneuver time is again correlated with the speeds, and you can see for a speed of 30 kilometers per hour, it is being defined as 8 seconds. But when it increases to 100 kilometers per hour, then this is 14 seconds. And this is one value which we will be using when we will talk about the calculations of overtaking maneuver time. Now, when this thing is happening, this overtaking is happening, when the vehicle comes here, then obviously it is accelerating, and therefore acceleration rate will be required. And this acceleration rate is being given here at a speed of 25 kilometers per hour. This is 1.41 meter per second, that is second square, or for a speed of 100 kilometers per hour, this reduces to only 0.53 meter per second square. So, at what particular speed you are trying to overtake, and then how much acceleration you have been able to get. So, as to do that is again dependent here on the speed, and this is one another rate which can be utilized while talking about the overtaking time or overtaking distances. Another factor which we need to look at is the heights. There are different heights which are there, because you are driving a vehicle. So, in that vehicle, when you are there, So, your vehicle is moving like this in this direction and you as a driver is looking from here. What exactly you are trying to look is what we are talking here. So, when this height is being talked, this is one height which we need to look at, the height of the eye level. So, this is 1.2 meters. If there is an object which is lying here at some point, then the height of this object is another thing which we are talking about, that is being considered as 0.15 meters. And the headlight which is there, the height of the headlight is another thing which is being talked and which is being taken as 0.75 meters. And you can understand when we were talking about the height of the headlight means we will be talking about the headlight side distance in that case. Again, the angle of beam of the headlight is also there, which is treated as 1 degrees upwards or downwards. So, if I consider on a plane surface, this is my horizontal, then the beam is going in this form, either 1 degrees here or 1 degrees on this side. So, this is another aspect which is going to be there. Just look at the same things here. So, you have this height of the driver, there is the height of the headlight, there is an angle of the beam. So, what they are going to define? They are going to define the distance up to which you are being able as a driver to see, and at the same time what is the nearest thing which you are going to see as an object. So, if there is an object here, you will be able to see that also, or otherwise in the whole view frame whatever is going to be there. And when you are looking at the horizontal aspect, so the angles are going to be say alpha. So, it is going to define the extent in which the total space on the road which is going to be covered and which comes under the view frame, and you will be able to see all those things which are there in that. So, these are the various factors with the help of which we can formulate the various distances in terms of stopping distances, over distances, etc. And with that we close our interaction here, and we will be now moving into the calculations of the various distances. The to be taken first is the safe stopping side distance. Thank you and bye.